Hello, welcome to Monday. Good Monday morning, or whenever you're watching this. Um, there I am in my makeshift classroom, uh, kitchen for some of you, and gonna go over that homework that you had last week on the factorials and the permutations, and then might take a couple videos to get through. Then there will be a video on the next combinations and an assignment. So um, get back to me in that lower corner. All right. So if you remember factorial, that exclamation point just tells you to 5, 4, 3, 2, 1. 5 times 4 is 20, times 3 is 60, times 2, 120. If you don't want to go through all that or something where like 8 is a little bit bigger, remember I did say you could come over here to Desmos. We're not graphing, so don't worry about the graphing. Let's come down to the scientific calculator. It's working. Give a second. All right, so your factorial, so 5 under functions is your factorial. So 5 factorial, 120. Hit enter, I'll keep it there. You can clear. The next one was 8 factorial, so back 8, down to functions, factorial. You don't have to go back, you can use your keyboard. Last one I think is 0 factorial, so I'm going to do 0 on my keyboard, factorial. You'll see 0 factorial is 1. So that's a big one to remember. 0 factorial equals 1. So 40, 40,320 is that 40320 and 0 factorial 1. All right. Hope everyone had a wonderful spring break, week off of school. I sat around, spent a lot of time on my couch, watching way too many Netflix shows, Hulu, Disney Plus, Amazon Prime, just streaming everything. All right, so I'm gonna do it down here. Remember that P52 or what would be 5P2. You can do it a couple different ways. This is just find the value of each one. So actually, we can go to the calculator. I wonder if I can shrink this. Hmm, not sure. All right, so the permutations are here. Um, when you press that, it was 5 comma 2, so 20 would be the answer. So if we're just evaluating, you can go straight to your calculator. So 5, 3, and 6, 4. So P with 5 comma 3 and 6 comma 4. So 60 and 360. 60, 360. Then 10, 4, 10, 5, and 5, 5 would be 10, 4, 10, 5, and 5, 5. All right. So 50, 40, 30, 240, and 120. 50, 40, 30, 240, and yeah, I don't know if that was right. That'd be the same as, let's go back and check. 5040, 3240, and 120. Okay. This, the 120, we got over here, the last one. And there's a reason for that. And if we go into the third page, number 3, oh, I think I just went one too far. Okay. If you're writing it, oh, actually, skip over to number 4 while we're thinking it, because this 5, 5 is, if you're writing it as multiplication, well, we'll start here. 6, 3 means you start with 6, multiply down, but just the first 3 numbers. So it'd be 6, 5, 4. The 30 times 4 is 120, or 20 times 6. 15, 3 would be 15, 14, 13. So grab my calculator for that one. If you're using a calculator, 15, 14, 13. Oh, 15, 14, 13. 2730. That's 2730. But on your calculator, if you're using one of the TIs, you can go over, there's a math button, go all the way over to the probability menu. You probably can't see that. And you'll see the NPR and the NCR. With the calculator, though, you have to put the number first. So if you're going to do 15.3, you have to do 15, go to the math, over to the probability menu. It's number 2 for NPR, and then the 3. And you'll get 2730. But so, yeah, so 5, 5 means you would do 5 in all 5 numbers. 3, 2, 1. So that's the same as 5 factorial, which we already said is 120. So if you have a double number, 10p10, or permutating, p1010 would be 10 factorial. So then if you remember our formula for factorial, go back to number 3, wait for the slow computer. Okay. If you have n comma r, then it is n factorial divided by, and you subtract them, n minus r factorial. Well, the last one said do not solve, and I solved it. You don't have to solve these. But if you're going to put this in formula form, it's 12 factorial divided by, and you subtract. 12 minus 5 is 7 factorial. And if you put that in your calculator, you'd get the same answer as doing 12 times 11 times 10 times 9 times 8, or 12p5. So 14.3 is 14 factorial divided by 3. Oh, why did I say 3? Then subtract 14 minus 3 is 11 factorial. And 9p9, and this is where I was saying earlier, it'd be 9 factorial divided by 0 factorial. And that's why it's important to remember that 0 factorial is just 1. So 9 factorial divided by 1 is just 9 factorial. That's a factorial. Wonderful writing. See, I'm using a slate. I can't see on here, but it writes on my screen, so. All right, moving on. Wore my shirt to make you feel right at school. I don't know if you need the video or not, but 4, all right, 5. All right, so then it got into the word problems. And like I said, if you're putting things in order and they are dependent situations, you can't use the same thing twice. If you have a summer baseball league, 15 teams, how many ways could you do the top five? Well, that's putting them in order, first place, second place. And if a team is in first, they can't be second, so it would be dependent. So this would be 15P5, or you could write it the other way with the parentheses, which would be the same as 15, 14, 13, 11, 10. If you want to put in your calculator that way, or 15 over the math, P5, or use the Desmos, but you end up with 360, 360,360 different ways the top five could finish out of 15 teams. All right, hope you got that one right. I think all of these. How many words, and words is in quotes because some of them wouldn't be real words, but if you took all the letters of insulate and arranged them in every different possible way, since each 1, 2, 3, 4, 5, 6, 7, 8, since all of the 8 letters are different, then and order matters, then this is just 8 factorial. All 8 letters are different, so switching them would make a whole different word every single time. That factorial is also on the calculator under that math menu over to probability. There's an exclamation point, the fourth one down, 4, 0, 3, 2, 0. Or you could do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right. How many ways can a baseball manager set his batting order for his 9 starters? Again, he's putting all 9 of them in order, so 9 factorial. 9 over the math, probability, number 4, 3, 6, 2, 3, 6, 2, 8, 8, 0. All right. How many ways can 6 students be placed in a row? All 6 of them put in a row, which means orders 6 factorial. 6 factorial, 720 different ways to put 6 students in a row. If a teacher has 15 students in class, how many ways can she line 6 of them at the door? Well, now you're not putting all of them, just 6 out of the 15. So that would be 15P6. And again, you could do it first 6 numbers starting with 15. For this one is probably easiest just to throw into the permutation in your calculator. 3, 6, 0, 3, 6, 0, 0. So 3,603,600. Number 10, in how many orders can 2 colors be selected from a box of 12 crayons? So you're selecting 2 colors in order. How many orders? So that is a permutation. If the first color is drawn, not replaced, so that is 12P2. Well, that's one of those where you might as well just do 12 times 11 and be done with it. 12 times 11, 132. So part 2 of this will be the rest of the homework. So check those and then go to part 2. I'll see you in a minute.